Good afternoon. Now we are going to see the steps which you have to follow while going for analysis of gantry girder. So, of the assignments already given to you. So now you can see we have this is span of crane girder. Now try to understand. Span of crane girder moves in longitudinal direction and its span is around 20 meter, 22, 18. Likewise, so we have span greater of crane girder and span of gantry girder is smaller, and that in on that our wheels will move on gantry girder along the longitudinal direction. Try to understand. Span girder moves along longitudinal direction and the wheels of span girders will move on gantry girder. Now we have these two wheels which are on the crane girder and which moves in lateral direction. So these are the wheels of crab which is going to lift your load or which will lift crane capacity load. So these two wheels move in lateral direction and the move of the wheels of crane girder will move in longitudinal direction perpendicular to this. So now we have these wheels or we have this crab which will move towards the reaction, maybe left or right, and that reaction are again two wheels of crane girder which will move on the gantry girder. Try to understand. These wheels are crabs, wheels of crab, which will move on crane girder, and the wheels which are of crane girder. So this reaction which I am showing you here, so this reaction is nothing but loads on wheels which are of crane girder. So now we have these two wheels and this wheel will move towards a left. And how much distance? So you can see we have this distance as hook approach. Beyond this, your wheel cannot be moved. So we have this hook approach distance which is already given to you. So you have to keep these wheels at a distance on hook approach. Now the distance between the two wheels, so this distance I will say, so we have this distance and that distance is nothing but wheel base. So we have this distance which is equal to wheel base. This is most important, and wheel base we have generally 2 to 3 meters, and accordingly we have to keep, sometimes it may be less depending upon your crane capacity. So now we have this crane capacity, and this crane capacity plus weight of crab that will be shared by these two wheels. So whatever values we will get of crane capacity and weight of crane, weight of crab or motor, that will be carried by these two wheels. So we can have this wheel load, and that wheel load equal to crane capacity plus weight of crab and motor, etc. So now we have these loads. uh, in the wheel load, whatever total load we will get, we have to divide this total load by 2. If I will say we have this total load, that is equal to W. So if I will say this load is capital W, then we are going to get these wheel loads this will be W by 2. So we have this as W by 2, and we have this value also W by 2. So knowing these values, we are in position to find this left reaction. And by this left reaction, we have loads on the wheels which are of crane girders and which will move on the gantry girder. So now you can see left reaction is shared by two wheels which moves on the gantry girder, and these wheels supports your crane girder. Now I will show you how these wheels will be. This is span of gantry girder, and this will move. These wheels will move on the gantry girder. Now knowing this reaction, so to find this reaction, we have to take moment about right reaction, and then you will get value of left reaction, or you can take moment about left reaction, you will get a right reaction, then by total W minus right reaction will gives you left reaction. So now we are with this left reaction, and from which we are going to get values of these. So I will say this reaction we have that is equal to R. And now we have these loads on the gantry girder by these wheels, and these values we have R by 2, and this R we have left reaction which we have calculated by wheel loads. Now we will go left reaction we have already mentioned, shared by two wheels which moves on the gantry girder. Now we are interested condition for maximum shear force. So now what is condition for maximum shear force? One of the wheel on the reaction. So if we are going to find out reaction, then left wheel will be on the left reaction. If we are going to find right reaction, a right wheel will be on the right reaction. And we have already calculated these values of the loads. So we have this value that is R by 2. So we have this value R by 2, and we have also this value same because these will be shared by both wheels equally, and therefore we have both values. These are R by 2. And we know we have this distance. This is wheel base. So we have this as WHL, wheel base. So I will mention it as WHL. And then knowing this wheelbase, knowing this gantry girder, we can find reaction that is left reaction, which we will mention as RSA. And this left reaction is nothing but maximum shear force. So we have this as maximum shear force. So I will mention it as maximum shear force. And knowing this maximum shear force, we can go for the further calculations. So we have maximum shear force, that is nothing but RSA, reaction for maximum shear force at A. Then reaction RSA will give maximum shear force. Now we will have condition for maximum bending moment. This is most important. One of the wheel load and CG of the wheels should be equidistant from center. This is most important. One of the wheel load and CG of wheel loads. Now you can go with this. So we have this as span of gantry girder. I have shown on large scale. Span of gantry girder is around 6 to 8 meters, and span of crane girder is 15 to 30 meters, we can say. So now we have this is L by 2. L is span of gantry girder. Now our condition is equidistance from center. So I have taken this as L by 2. So I have this will be L by 2 line. Now what we have to go? One of the wheel and CG of the wheel load. So we can have this CG of the wheel load and one of the wheel equidistance, means we are going to get this distance WHL by 4, this distance should be WHL by 4, that is CG, and then that will be equidistance. So now you can see we will move this. So it will go in such a fashion that this is WHL by 2, that is distance between the one of the wheel and CG of the wheel load, because it is at center, because we have both values of the loads are same. So this is WHL by 2. Now what is our condition? So we have CG of the wheel load and one of the wheel load should be equidistant. So distance between these two, we have WHL by 2. So distance from CG of the two should be equal. Means we have WHL by 4, we have WHL by 4. So now we are with this condition. So our one of the wheel load is on left, that is at WHL by 4, and CG of the wheel load will be at WHL by 4. So if I will write distance of another wheel from CG, and that distance we will get it as 3WHL by 4. So we have this distance 3 by 4 WHL. So directly you can use these distances. So WHL, and what is WHL? We have already seen. WHL we have wheelbase. So we have to keep one wheelbase at WHL by 4 from center. So this you can see one wheel is at WHL by 4 from the center, and another will be at 3 by 4 WHL from the center. And then we will find the reaction. So this we will give you a reaction for maximum bending moment. Now once we will get this reaction, you can take moment about right reaction, and from this you will get value of RMA. Once we know RMA, then we have to take moment about the wheelbase, which is near moment about wheelbase, which is closer to center. Will about will which is closer to center. So which is closer to center. Which is closer to center. And likewise, we will get value of maximum shear force, and we will get value of maximum bending moment. So closer to center. And likewise, you will get, or you have analysis of this gantry girder. So this is very simple, and we have to take moment about this wheel, because this is at WHL by 4 from center, and this is 3WHL by 4, and this will gives us maximum bending moment. So we will stop here only. Thank you.